All right, ladies and gentlemen, today we are looking at order of operations. So when you've got a bunch of multiplication, addition, division, exponents, parentheses, you've got that and a bunch of numbers in there, so you've got some big numerical expression. How do you evaluate the value of that expression? How do you figure out what value it's equivalent to? Well, you have to follow proper order of operations. The order is usually remembered by the acronym PEMDAS. Oftentimes people will use little mnemonic devices, some phrases to help them remember, the most common one being, "Please excuse my dear Aunt Sally." I don't know who Sally is, but apparently we need to excuse her. I'm not a big fan of that phrase, to tell you the truth. I always just remembered PEMDAS because it kind of sounds like a word. So it didn't really bother me to remember that. But, maybe you want to come up with your own little individual phrase to help you remember. More importantly, though, you still got to remember what all those letters stand for. If you don't, it's kind of useless to remember the letters in the first place. P is parentheses, but it also includes any other symbols of inclusion. And we kind of mentioned that in one of the previous note sheets. Really, it's just any type of symbol that groups operations together, meaning when those operations are grouped together, you got to do those first. So that could also include brackets, and it could also include the fraction bar. When you see a fraction bar, the top numbers and the bottom numbers are all grouped together, so you have to simplify your numerator and your denominator first before simplifying the entire fraction. Most of the rest of these are a little bit easier. E is for exponents, so you need to evaluate your exponents first. M and D, A and S, those are your four basic operations: multiplication, division, addition, subtraction. I won't even bother writing those down. But what I will do is I'm going to box them in, because really our order of operations goes parentheses, then exponents, then multiplication and division together, then addition and subtraction together. Since multiplication and division, as well as addition and subtraction, are basically the same process, we do them all in the same step, but you want to make sure that you do them from left to right. This especially becomes important in the addition and subtraction stuff. People will forget it there because they'll see something nice that subtracts first, or they'll do the addition first even though they're not working from left to right, and it screws everything up. So you want to make sure you work left to right when you're doing your multiplication and division and your addition and subtraction. That's really important. The one question that I did ask last year to all my classes was, could you prove that this order is correct? And how would you manage to do that? And now, I don't mean, well, if you don't do it in this order, you get the wrong answer. Well, yeah, but how do you know that's the wrong answer? How do you know that, that someone didn't just kind of make this up and we all have to follow it because they made it up? That's not what happened. This is the order that it has to be. How would you prove that this is the order that it has to go? This might be something that you consider. It's not necessarily something I'm going to give you the answer to, but it could be something to think about. It could be something to discuss in your groups tomorrow. So just throwing it out there. Okay. Let's get some practice in. I've got a wide range of practice problems here. And then we've even got some on the reverse side that are going to involve variables. So, I usually like to write my order of operations acronym over somewhere when I'm doing these. That way I don't forget. So looking at this first one, I see no symbols of inclusion. I see no exponents. I do see multiplication, though. I see a 4 times 2, so I'm going to do that first. 4 times 2 is 8. I see no more multiplication or division. I do see some subtraction. 34 minus 8 is 26. Notice how I try to keep everything kind of in line a little bit. Okay, it's not perfect, but you can kind of see where everything is coming from when you keep everything nice and lined up. Okay, so that's kind of important to do, and you want to try to work nice and vertically whenever you can. Okay, why don't we do this? Why don't you guys try B? You guys try B, pause, and then come back. Okay, at this point, I'm assuming you have tried B. You need to evaluate the entire expression in parentheses first, and you have to follow order of operations inside the parentheses. So we need to do 6 divided by 2 first because division comes before addition, and then we can transform that into an 8. Now the question is, what operation is between the 7 and whatever's in parentheses? Well, we assume that to be multiplication. When you see a number next to parentheses, or a variable for that matter, you assume the operation is multiplication. Next, now we've got no more symbols of inclusion, but we do have an exponent that we need to evaluate first. 2 to the 4th is 16. 4 2's multiplied 16. Next, we got to do multiplication or division. We have some of that. That is 7 times 8, which is 56. You need to do the 60 minus the 56 first. We're working our way from left to right. So that gets you 4, and then 4 plus 16 is 20. So hopefully you got that one right. Let's go ahead and do the same process for C. The big thing that I will point out right away is once you see this fraction bar, it's like you're assuming your numerator and denominator are in parentheses, so you need to evaluate them first. So again, pause and then go ahead and come back when you're ready to see what the answer is. Okay, so at this point, I'm assuming you've evaluated, our numerator becomes 2 times 16 minus 4, which becomes 32 minus 4, which becomes 28. So that's my numerator. My denominator becomes 13 minus 6, which becomes 7. And 28 over 7 is 4. D, there's a reason I put this on here. It's not really anything harder. All you're doing is plugging in the value of a variable first. That's not really that big a deal. However, when it's a negative, people tend to make mistakes. When you plug it in, I like to put it in parentheses where the x was. Now the squared stays on the outside because I'm just replacing my x with a negative 4. But the reason I like to use parentheses is because now it's clear that I am squaring negative 4. Okay, that becomes very clear now that I am squaring negative 4. So negative 4 times negative 4 is positive 16. A lot of people mess that one up. Now I'm going to get rid of the parentheses over here because I didn't really need them. I put them in initially, but now I can just write that as multiplication. Or you could leave them there. That notation works too. Do both of your sets of multiplication. 3 times 16 is 48. I'm going to leave that as a subtraction sign and then do 5 times negative 4 is negative 20. Minus negative 20 is the same thing as plus, so we get 68. At this step, you could have worked it slightly differently, and if you did and you got to the exact same answer as 68, you're probably fine. Okay, last bit is now a little bit of translation. Okay, we've done some of this before, but now we're going to take words and we're going to put them into some kind of algebraic expression. Here's the key. You want to use parentheses or a symbol of inclusion only when necessary. Okay, so for B, add 5 to y and then multiply by x. It's implying that 5 plus y, or y plus 5, needs to go first. So I'm going to put that in parentheses and then multiply by x, so times x comes after it. Now the question is, did I need to put parentheses there? Think about that question for a second. The answer is yes, I did need to put parentheses there because if I didn't, order of operations would say that I needed to do the 5 times x first. Okay, so I definitely need parentheses there. So looking at C, why don't you try coming up with one for this one, pause, and then come back when you think you got an answer. Why don't you do both C and D, actually. Do C and D, and then we'll come back and take a look. Okay, so we need to add the product of 5 and y to x. The product of 5 and y is 5y, or 5 times y. And if we're adding them, adding it to x. We don't need any parentheses there because we're going to do 5 times y first, and that's okay. D, 6 more than the quotient of 6 divided by x. That's 6 over x, 6 divided by x. You could use a division symbol if you want. 6 more than that would be plus 6. Hopefully that worked out well for you. The translation can be a little bit tricky sometimes, but hopefully those weren't too bad. That's it for today. Hope you learned something.